Hello everyone, welcome back to my channel Sneh Classes. This is our next lecture of introduction of matrices. We have already heard about what is a matrix. Okay, matrix is a rectangular array of elements arranged in rows and columns. We will denote the matrix by a capital letter, or huh, we can denote the element of a matrix by telling about its row and column, like Aij, where I is the ith row and J is the jth column. Okay. Now this is the example of a 2 cross 3 matrix. Okay, next, what is the order of a matrix? Order of the matrix is defined by the number of rows and columns. Okay, if rows are m number of rows and n number of columns, then the order is m cross n. Okay, this is the example of a matrix which has order 3 cross 2. We can see here we have 3 rows and 2 columns. What are the different types of matrices? We have this much types of matrices. We can see here row matrix with only one row, column matrix with only one column, square matrix, row equals to columns, diagonal matrix, all non-diagonal elements are zero. Okay, and on diagonal elements we have some numbers. Okay, scalar matrix is a diagonal matrix with same diagonal element. Okay, identity matrix, diagonal matrix with one once on the diagonal. Okay, next, zero matrix, all elements are zero. Symmetric matrix, A transpose equals to A. Skew symmetric matrix, A transpose equals to minus A. We'll discuss about transpose in next slides. Okay, matrix addition and subtraction. Matrix can be added or subtracted if they have the same order. Okay, we will do the addition and subtraction element wise. Okay, now we have here an example where A equals to this 1 2 3 4, B is 1 6 7 2. Now we perform addition as 1 plus 1 and 2 plus 6, 3 plus 7, 4 plus 2. Now you know the adding. ठीक है, we will do subtraction in the same way. Okay, now next is scalar multiplication. How do we perform scalar multiplication? Scalar is a constant number. Okay, if we have a matrix A equals this and K equals 3, then if we multiply A with 3, like 3A equals, we multiply each element of A with 3. Okay, that is the scalar multiplication. Now next is matrix multiplication. Matrix multiplication is defined only if the number of columns in the first matrix, that is A, equals the number of rows of second matrix. Okay, if the order of A is m cross n and B is n cross p, then then the matrix multiplication AB is possible and it has the order m cross p. Here we can see that जो दोनों के ऑर्डर में, मतलब फर्स्ट वाले के ऑर्डर में पीछे वाला नंबर और सेकंड वाले के ऑर्डर में आगे वाला नंबर, ये सेम होने पे मैट्रिक्स मल्टीप्लिकेशन होगा, अदरवाइज नहीं होगा. ठीक है, और मैट्रिक्स मल्टीप्लिकेशन में क्या करते हैं हम कि जो ए की रो है और जो बी का कॉलम है उनका डॉट प्रोडक्ट करते हैं. ओके, इफ यू हैव एनी प्रॉब्लम देन कमेंट मी इन द क्वेश्चंस. ओके, then comment me the question, sorry. Now, this is the transpose of a matrix. How we perform the transpose? For the transpose thing, we have to interchange rows and columns. Like here we have the example A is 1, 2, 3 and 4, 5, 6. Now we convert this 1, 2, 3 in a column which become 1 ऊपर 2 नीचे 3 उससे नीचे. ओके, एंड सेम विद द सेकेंड रो 4 5 6, इसको हम बनाएंगे सेकेंड कॉलम, दैट इज 4 5 6. रो एंड कॉलम्स इंटरचेंज हो गए हैं. दिस इज द ट्रांसपोज ऑफ अ मैट्रिक्स. ओके, नाउ For symmetric matrix, this transpose is always equal. Okay, and if the matrix is uh, skew symmetric, then this transpose is negative. A equals to minus of AP. Okay, when we will perform questions, we get this. Okay, determinant of a matrix. How we find the determinant? Determinant is a scalar value that can be computed from a square matrix. The main thing to calculate the determinant is that the matrix must be a square matrix. Okay, we'll denote it by det of A or A between the modulus. Okay, ठीक है. If we have a 2 cross 2 matrix with the elements A and B, and in second row it's C and D, then the determinant of A is equals to AD minus BC. We are going to do many more questions on this determinant of a matrix. Okay, don't worry. Now, inverse of a matrix, the inverse of a square matrix A is another matrix A inverse such that A multiplied by A inverse equals to I, which is identity matrix. And we can calculate inverse of a matrix if and only if the determinant of A is not equals to 0. Okay, we have the formula for A inverse. We are going to do questions on this. Okay, chalo. Now, what are the different application of matrices? We use matrices in solving the linear equations by using matrix method. Okay, and in computer graphics we use transformation of matrix. Okay, and we use it in network analysis, economic and statistical models, physics, cryptography, encoding, and etc. Okay, now what we got? The matrix is a key tool in linear algebra. और बेसिक टाइप्स क्या है? रो, कॉलम, स्क्वायर, डायगोनल, ये मैट्रिक्स के टाइप्स होते हैं मेनली. ठीक है. ऑपरेशन कौन से होते हैं? एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, ट्रांसपोज, इनवर्स. ओके, और ये कहाँ कहाँ मेनली यूज़ हो रहा है? साइंस, इंजीनियरिंग, इकोनॉमिक्स, कंप्यूटर साइंस, एक्सेट्रा. ओके, thank you. If you have any questions, let me know in the comment section. I'll be replying all of your comment and questions. Okay. Listen, friends. I'm going to attach a question PDF with this. Okay. Now you can try them. If you have any doubt in that PDF, you can ask me the question in comment box. Okay. Okay then. Bye bye. Take care.